Hey Chemistry, Mrs. KJ here, going over Lesson 4.06, Review Ionic Compounds. Review concept presented in the lessons, the ionic bond in salts, and properties of ionic compounds. Again, we have our goals for the lessons. Describe how metallic bonds form, describe an ionic bond, define a salt as an ionic compound, analyze the repeating patterns of positive and negative ions in salt crystals, such as table salt, determine what holds the positive and negative ions together in crystal salts such as sodium chloride. List and discuss some of the properties of ionic compounds. Explain how the nature of ionic bonds accounts for various properties of ionic compounds. Explain why ionic compounds are excellent conductors of electricity when dissolved in water. And you can go in and download the study guide if you'd like, or just take notes. All right. Salts are formed from a metal and a nonmetal. The metal loses electrons, becomes a cation, which means it has what kind of charge? Positive. The nonmetal gains electrons, which makes it an anion, and it has a what charge? Negative. The cation and the anion are held together by an ionic bond. We could also say they're held together by the electrostatic forces, so the fact that positive and negative are attracted to each other. Metals, groups 1 through 3A, combine with nonmetals, groups 5 through 7A, to form ionic compounds or salts. So remember, table salt, NaCl, is of course what we commonly call salt, but salts are any ionic compound. The metals give up their valence electrons to the nonmetals to form metal cations. The nonmetals take valence electrons from the metals to form nonmetal anions. The metal cations and nonmetal anions form electrostatic interactions, so the positive and negative are attracted, which we call an ionic bond. Ionic bonds are stable chemical bonds, not weak associations. Weak associations are usually when we talk about the fact that one molecule wants to be near another molecule. This is just simply, basically like superglue, a very strong bond. The metal ions and nonmetal ions are bound together and arranged into crystal lattices. Each crystal lattice has a repeating unit, called a formula unit, of alternating metal cations bound to nonmetal anions in 3 dimensions. A formula unit is the lowest whole number ratio of metal cations to nonmetal anions in an ionic compound. So in other words, the chemical formula. We just call a formula unit, and that's our repeating amount that's going to be in our pattern. Ionic bonds are between a metal and nonmetal. The properties: they are strong. They may dissolve in water to form a solution that conducts electricity. And are they bendable or brittle? Brittle. The electrostatic interactions, the fact that positive is attracted to negative, between ions makes the ionic bond very strong relative to other types of bonds such as covalent bonds. They're just sharing the electrons. The ionic, that positive-negative, is a real strong pull. The strong ionic bond requires high energies to break in or loosen the bonds. As a result, ionic bonds have a high melting point and a high boiling point. It takes a lot of energy to rip those bonds even just a little bit apart to change from solid to liquid to gas. And of course, these high points are relative to elements that make them up or to covalent compounds. The strong ionic bonds hold the ions tightly packed in a crystal lattice. Ionic compounds are hard and brittle, so brittle, not bendable. So they'll break, not bend. In solution, water molecules surround ions, interact with them, dissolve the crystal, and allow the ions to move freely. And that moving freely is going to be the movement of electricity. All right, let's go ahead and do our problems in the problem book. So we have problem set 19, the ionic bond and salts. Objectives: define an ionic bond, describe the arrangement of ions in a solid salt. Cations and anions attract one another and form ionic bonds. Compounds held together by ionic bonds are called salts, or ionic compounds. Positively charged ions are called cations, and negatively charged ions are called anions. These oppositely charged ions have an electrical attraction for one another and can form ionic bonds. Substances that contain ionic bonds are called salts. In the solid state, salts form crystals. If you could see the ions making up a crystal, you would see that the cations and anions in the salt are arranged in a regular, repeating pattern, which is reflected in the shape of the crystal, so that nice cube. The net amounts, so the total amounts of positive and negative charge in a salt are always exactly equal. So the salt has no overall electric charge. So table salt is neutral. Yes, the sodium is positive. Yes, the chlorine is negative, but 1 minus 1 is 0. Therefore, you can predict the chemical formula for an ionic compound if you know the charges of the ions in the compound. Remember, an ionic bond is the result of electrostatic attraction between positively charged ions, cations, and negatively charged anions. The net total electric charge on an ionic compound is always 0. An ionic compound can be made of monatomic ions, so in other words like the sodium or the chlorine, or polyatomic ions like sulfate or phosphate, SO4, PO4, all those ones that are listed on your polyatomic ion cheat sheet. Metals, oxygen, and the halogens, group 7A, most commonly form ionic compounds. Oxygen and the halogens tend to form anions, metals tend to form cations. All right. So barium chloride is a salt that gives some fireworks a bright green color. Write the chemical formula for barium chloride, which forms from the monatomic ion of barium plus 2 and chlorine minus 1. So hit pause, get your answer. To form a barium plus 2 ion, a barium atom must lose 2 electrons. To form a chlorine negative 1 ion, a chlorine atom must gain 1 electron. To maintain electric neutrality, any electrons lost by barium atoms must be gained by chlorine atoms. All right, so I like the simple crisscross applesauce that I've been showing you guys. Another way to think about it is this way. Each chlorine atom can gain only 1 electron, but barium atom loses 2 electrons to form barium plus 2 ion. The 2 electrons that are in the barium atom and are lost must be taken up by 2 chlorine atoms, so 1 electron per atom. Therefore, each barium plus 2 ion must be bonded to 2 chlorine minus 1 ions, and the chemical formula for barium chloride must be BaCl2. To check that this formula is correct, add the charges of the ions in the formula. The net charge on a BaCl2 formula is plus 2 times negative 1. So in other words, the barium was plus 2, the chlorine's minus 1, but there's 2 of them, so 2 minus 2 is 0. Which of the following pairs of atoms is most likely to form an ionic bond? Carbon and nitrogen, silicon and oxygen, bromine and bromine, lithium and chlorine. Hit pause, get your answer. Tip: when describing the bonding in a compound or writing the chemical formula for a compound, always locate the elements in the compound on the periodic table first. The position of the element on the periodic table can give you a lot of information about its chemical property, including the types of bonds it tends to form. For a pair of atoms to form an ionic bond, one of the atoms must lose electrons to become a cation, and the other atom must gain those electrons to become an anion. Remember that elements with similar electronegativities tend to share electrons, so like the nonmetals, right? Like this one where it's the exact same element, it's going to share, rather than transferring them. The closer two elements are on the periodic table, the more similar their electronegativities are. Therefore, the elements that are farthest apart on the periodic table are most likely to transfer electrons and form an ionic bond. In other words, a metal and a nonmetal. So you locate all of them. We have nonmetal, 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 metal, nonmetal. Whoa! We have one metal. So our answer is D. All right, for our problem sets, we are supposed to do 1, 2, and 3. 1. Which of the following pairs of elements is most likely to form an ionic bond? Hit pause, get your answer. All of them listed here are nonmetals except for potassium. You need a metal and a nonmetal. So the answer is B. 2. Explain why salts are electrically neutral. And 3. Define the term crystal in your own words. So all right, so hit pause, get your answers. So the overall charge on an ionic compound always equals 0. So you take the charge of the cation and the charge of the anion, and how many of each atom there are. So table salt's easy, NaCl. Na is plus 1, chlorine's minus 1, 1 minus 1 is 0. The example they gave us here was where we have BaCl2. Barium, each one atom is plus 2. Chlorine's -1, but there's 2 of them. So it's 2 -1 -1, right? You'd have to -1 twice. Or if you do the work ahead of time, it is +2 -2 equals 0. So the overall charge, when you take the charge of all the atoms that are involved in the compound, are going to equal 0, and therefore it will be neutral. Define the term crystal in your own words. Well, it's your own words. If I had to do it, I would say, well, it's the three-dimensional form, like a cube, that's formed when you have the repeating of the cation and the anion in an ionic compound. So basically, you want to make sure you have some positive and negative, the fact that the positives are always going to be surrounded by the negatives, and that's going to give you that nice form, usually a cube. Properties of ionic compounds. Describe some common properties of ionic compounds. Explain why salt solutions tend to be excellent conductors of electricity. Most ionic compounds are solids at room temperature, have high melting points, and conduct electricity well when they dissolve in water or are melted. Many important minerals and gems, including garnet, which happens to be January's birthstone, ruby, which is July's, emerald, which is May's, hematite, which is an iron ore, really beautiful shiny black, and fluorite, are ionic compounds. The ions in ionic compounds form a regular, repeating pattern in a solid state. This pattern results in the formation of crystals, which are solids with regular atomic structures. The arrangement of the ions in a crystal determines the shape of the crystal, which is why gems and minerals form crystals with specific shapes. So I said that they're usually cubes. I should definitely redefine that. I mean, you can think of a diamond, which is like a cube, but if you've ever seen diamond rings, they can be cut into many different shapes, like a pear shape, or the star cut, or an heart shape. Okay, and some are naturally just found in different geometric shapes, but it's usually they have the real nice edges, and that's part of the crystal formation. Remember that the ions in an ionic compound are held together by electrostatic attraction, so positive is attracted to negative. That is, the cations and anions are attracted to each other because they have opposite electric charges. The ionic bonds in ionic compounds are very strong. These strong bonds affect many of the properties of ionic compounds. Describe the properties of ionic compounds. A scientist is studying the properties of ionic compound. Which of these properties does the compound most likely have? A. It has a net or total positive charge. B. It does not dissolve in water. C. It is a gas at room temperature. D. It has a high melting point. So again, if we're thinking of ionic compounds, what should be in your mind? Table salt. So which one of these are true? Hit pause if you need to think about it. And the correct answer is D, because the net charge is going to be how much? 0. The total charge of the whole compound is 0, even though it has positive parts and negative parts. They add up to 0. They will dissolve in water, and usually they're solids. Properties of ionic compounds. Most ionic compounds, or salts, are solids at room temperature. In the solid state, the ions in the compound are arranged in a regular, repeating pattern. This pattern produces a specific crystal shape in the solid compound. Ionic bonds are very strong. Most ionic compounds have very high melting points. Most ionic compounds dissolve easily in water. Explain the electrical conductivity of salt solutions. Tip: the ions in a salt also dissolve when the salt melts, which of course takes crazy high temperatures, so that's not going to happen in your kitchen. Explain why salt solutions tend to be much better conductors of electricity than pure water is. All right, so hit pause, get your answer. For an electric current to flow, charged particles must move from one place to another. In a metal wire, the charged particles that carry the current are the electrons. In a liquid, ions carry electric current. Pure water contains very few ions. It's just H2O. When a salt dissolves in water, the ions in the salt dissociate or separate, and so they can rapidly carry an electric charge because of the positive and negative dissociated ions, so salt solutions conduct electricity better than pure water does. Read questions 2 and 3, hit pause, get your own answer. Okay, answer to number 2 is the salt. Because you have the positive and negative of the salt, the sugar is neutral. Answer to number 3 is the calcium chloride, because the positive and negative electrostatic is a very strong, tight bond. And so it will be held together real